Howdy, this is your friendly neighborhood physics teacher here, and I'm going to tell you what you're doing today. You're going to design a friction lab. Now, design, that means you're just going to figure out what would be the purpose of the lab, what what your procedure would be, what your data table would look like, what graphs would you draw. You're just designing the lab. You're not doing the lab. You're just designing. Okay? Friction lab design. You're just designing, you're not doing. So when we click on the PowerPoint that says friction lab, there's going to be a few things we're going to throw out. So design a lab determine both the static and kinetic coefficient of friction. So you are to design a procedure to determine experimentally, that means through experiment, the coefficient of static and kinetic friction between a block of wood and a surface. Now, you may not destroy or damage any equipment you use, and your method must be feasible and practical. So I'm going to give you a list of material, like equipment that you would use if you were going to sit there and actually do the lab. Just you can't that's all it means. You just can't modify the equipment. You got to use the equipment as is. And then, even though we're not doing a lab, you're just designing the lab. It still has to be physically possible. It can't all of a sudden you can't jump on a space station because as a class, sadly enough, I am not Miss Frizzle. I would love to be Miss Frizzle. We can't jump on our magic school bus and go to space. It's got to be something that we can feasibly do in the classroom. So this is where a few things are going to get modified here. So list the equipment you need, include a label diagram. So that means like kind of draw out what you think your setup would look like, and then list your equipment, label the diagram so I know that square thing is the block of wood you're talking about. Describe the measurements you would make. Assign each measurement um, a symbol, a variable. So T is time. Coefficient of friction is your funky little mu thing. I can remember your funky little mu thing, right? Yeah. And, coefficient of friction of static is with an S. Kinetic is a K. Remember, static means not moving. Kinetic means moving. Show explicitly using equations how the measure quantities would be used to determine the coefficient. Basically, they're saying what equations would you use? So again, you're not using numbers. You're just using equations. You're just using the variables. So do I want you to plug in numbers? No, no numbers. Discuss how are you reducing experimental error. So while you're sitting there making the experiment, what have you done to try to prevent human error? What have you done to prevent certain things to happen? Now, you can't really compare your results. So sadly enough, um, you're not doing that. And then you'll get a bonus if you can figure out what graph you would need to make to determine with the slope. So what graph would you need to make with your data? So remember, this is the data you've collected. That your slope would determine the coefficient of friction. So of course that's um, a super secret bonus. So it's not necessarily a secret. It's a secret that everyone knows. but that's still a thing. The only thing that we're taking away is you're not really comparing your results, because sadly enough, after you design your lab, you're not going to be able to make your lab. So, but you are designing a lab. Oops, let me get done writing. Now here is a list of your potential equipment. And what I mean by potential equipment is you don't have to use it all. I'm just giving it to you. So you have ramps. We've dealt with the ramps before. Of course, you have a flat table. You have a table. Table is an equipment. You have a ramp with an incline, and that incline can change. Don't worry about the different um, so we're just going to focus on the wood block. Save a little, oops. So we're just going to focus on the wood block. Apparently that moves with me. And then we do have a spring scale. You don't have to be specific on which spring scale. You don't have to be specific on which spring scale you would use. Again, that was if you're actually doing the lab. But you can just say you're using a spring scale. Remember, we use the spring scale to measure what force, how much force. Um, Now, you do need to be specific on the number of masses you're using, which mass, and stuff like that. So you do need to be specific on masses. And then what's not pictured is a scale. That's the thing that you mass objects with. And again, you don't have to use all of this material. You can just use some of it. But the goal of this lab is to figure out the coefficient of friction of wood. So that's where your wood block comes into play, compared to a surface. So if that's the surface of the table, which in our lab is that black top table, or if that's the surface of the ramp. So you have to design a lab and think again, when you make a procedure, you're going very step by step, and you're going to be very detailed in your step by step. And you're trying to find the coefficient of friction of static. Now remember, that means not moving. So trying to figure out what that coefficient of friction when your block can't move, and you want to be able to find the coefficient of friction of the block when it is moving. Now this is a lab. This goes back to how to make what you're doing to fix the experimental error. This goes back to this part. How are you going to reduce the experimental error? So think about doing it multiple times. Doing the trial multiple times. Doing it in different situations. That's where the different masses come into play and stuff like that. So just a couple of things to think about. You were just designing the lab. You were not doing the lab. Okay? You're just designing the lab. So think about you're a teacher making a lab for a student to do. All the information you would need to do is to help that student be able to do this experiment. And they're not an AP student that I just throw in, go here, do a lab. Think about You want your younger sibling, you want your baby cousin, you want the kid next door to do a lap, and how much detail would you need to give them? Okay, so I hope that helps. Hope y'all have a wonderful day. We'll work on this technically for today and Friday, um, and so that would be, and it will be due. Um, we'll make it due next Wednesday. I'll change the due date, so we'll make it due next Wednesday. Now this is a summative grade. This is a major grade. Okay, so remember you're loved and appreciated. Have a wonderful day. Bye.